Thanks everyone again for joining. My name is Dan Yeaw. I'm a functional safety manager at Ford Motor Company, and I'm the host of Michigan Python right now. And I'm really excited to give talk about building for the web with FastAPI. We should have fun this evening. Showing how FastAPI works. First, I want to go through kind of some background information, and then we're going to spend most of the time talking about the code and how you actually build this website. So I have two kids, and they're a lot of fun. My kids love Pokemon. I didn't really actually grow up with Pokemon too much, but my kids are obsessed with it. So they spend hours memorizing all 1,000+ Pokemon. They have these Pokédex books, and they sit and memorize what the Pokemon are. And so often I'm sitting at the dinner table with them, and they want to play this game that goes something like, I spy a Pokemon that is dark and poison type. And I have no idea. So I just say, I don't know any dark and poison types. I give up. If it's not like Pikachu or Rowlet or someone, I don't know. So, and then my kids, of course, I'm like, oh, Dad, come on. It was Overquill. Everyone knows dark and poison types. So what we're going to build tonight is a website that has all the Pokemon by type in it. And actually, I can show you what it looks like. So everyone has some context of what we're building. So it's just a simple website, and you can select a, say, dark, and select a poison type, and then you can click search. Uh-oh, that didn't work. Hold on.
Always for the live demo.
Yeah. I should probably actually run the server if I'm going to demo something. Sorry about that. Okay. All right, now we're running a web server. Sorry about that. So yeah, it comes back with all the dark and poison types. And Overquill is on the list, right? So this is kind of what the app looks like, and you can reset it and select different Pokemon. Sound like fun, everyone? Okay. So kind of some intro to some things. So I actually gave a whole talk on typing. If you want to know a little bit more about this, there's a previous talk on YouTube about this. But Python has a dynamic typing system. And that means at runtime, Python tries to figure out what the type of each object is. And that's different than a statically typed language where you have to statically define what each type is, whether it's a float or an integer or a string or some other data type. And those static typing languages check that all your types are correct during compile time. Python doesn't do that. It's got this dynamic typing system, which is also very flexible because you can override things dynamically, right? So one thing it does support, though, starting actually fairly recently in Python 3 and really got even more used in Python 3.6, is something called a type hint. So you can actually add types to your Python, but for the most part, it's just to help document your code. And it also provides nice support in your IDE or linters. So you can use some libraries called MyPy, where you can run MyPy in your code, and it'll look for issues with the types being defined incorrectly, or you're passing the wrong type of information from one function to another. And also the type hints help out with those IDEs so that if you're calling a function, it knows what type of variable or whatever you're passing into the function itself. So it can help kind of use autocomplete and stuff like that. More recently, there's actually extra libraries you can use, and we'll talk more about one of them called Pydantic, and it can actually support runtime checks. And we're going to use Pydantic as part of FastAPI. So that's why I'm kind of providing some intro to this. So this is a Python function with the name of headline. And it takes a piece of text, and then you have a colon, and this is the type hint. You're telling it, hey, this type of this text that's passing in my function is of type string. And I also have an align, and that's a Boolean, and it has this also has a default value. So if you don't pass align in, it'll by default go to true. And then this arrow on the end means that this function returns a string. And so this is what type hinting looks like in Python. It does add a little bit, maybe overhead to reading the Python. It's not as straightforward because you have this extra information, but it also really helps when you're working with others because you want to call a function, you know what you need to pass into it, not just in like a doc string or something like that, but you actually know the type that needs to be passed in and what you expect to have returned. So it's a little bit quicker and less error prone when you're trying to make use of those pieces of Python. So we're going to use a lot of libraries to build up this app. And there's like a saying that I learned Python, it was a great weekend, as a joke, right? But then I really feel like you could spend a lifetime mastering all the libraries of Python. And that's really what makes Python so great. Both all the libraries that are in the standard library and all the libraries that are pip installable. It's just got this vast ecosystem of great things that you can just pick up and go and make use of. And we're going to make use of some of those libraries today. So like I kind of said, these are your tools for your toolbox, and we're going to use a bunch of them in this project. Also, we're going to kind of go through the steps of building this simple app. So the first step is we need to get some data and process it. So what we're going to use for that is we're going to use Beautiful Soup, and it is for web scraping. So there's probably some data on the internet about Pokemon. So we can use a web scraper to go on a website and pull the data off the website and then get that data for us. Pandas is another library for working with data and allows working for data in a collection of columns called a data frame. I always kind of think of this as like Excel on steroids a little bit. This data frame has data in these columns with rows, and then you can modify and manipulate the data, and it's very powerful. Step 2, we are going to store the data in a database. For this project, we're going to use something called SQLite. It's this very fast, lightweight database. It means we don't need to have like a whole separate process running a database on a server somewhere. It's also very fast, and for the amount of data we're working with, it's perfect. In fact, SQLite is perfect for a lot of projects. It's actually very fast, lightweight, and kind of fun to use. And there's also a tool called DB Browser for SQLite. I'll show that a little bit. This is just a desktop app that helps you create, design, and edit database files that are compatible with SQLite. So I'll show you how we can take like a CSV, for example, and load it into the SQLite database. We're also going to develop Python schema. So there's a library called SQL Model. It was actually created by the same gentleman who created FastAPI. And it's a library for interacting with SQL databases from Python code with Python objects. So this is very similar to some of you have probably heard of other libraries like SQL Alchemy. However, SQL Model is a little bit different. It is based on Python type annotations and then has Pydantic. We just talked about that library a little bit. So Pydantic, remember, allows us to do runtime checks of those type hints, and also powered by SQL Alchemy itself. So it integrates really nice with FastAPI, so we'll make use of that as well. And this allows us, well, what I mean by Python objects is we can define the model our data is in Python code without having to use SQL queries themselves. So we don't need to write out SQL, we can just write Python. Step 4, we're going to develop APIs to access the data. And I would say like step 4 and 5, we're going to do iteratively a little bit. So step 5 is going to be actually creating the website itself. And you're going to need to do it iteratively because the APIs are the backend. What you're calling with a website is to get the data you need. So FastAPI is a modern, fast web framework for building APIs based on these standard type hints. I mean, it is very fast. It's on par with, yeah, the fastest other web frameworks out there, even in other languages like Node.js and Go. So it's an asynchronous framework. It's really fast to code. Having the type hints means there's fewer bugs. So this actually is doing runtime checks using those type hints on the data that you're using on the API. And so you pass data to the API and it's like, hey, I'm expecting an integer. It's going to check that you actually got an integer. And it's pretty intuitive and easy. Pretty lightweight as well, on par with something like Flask, but has kind of this special abilities using these type hints. FastAPI has also taken off. I think the framework is about 3 years old and it has something around 50,000 stars on GitHub. So it's become very, very popular.
Dan?
Yeah. Hi, Charlie.
And a quick comment about the UV, it was UV corn.
Yeah, so this is, I maybe didn't call this out while I was maybe going through each page, but this is like the pip install and how you install this. And UV corn, and there's also GUV corn. These are these kind of standard frameworks that help serve the data from the website we're making. So when I said, like, when I tried to load the website earlier and I was like, oh, it would help to actually have my website running. It was actually, I did not have UV corn running on my computer at the time.
Thanks.
Yeah, so it's actually like serving the data that we're requesting.
Is that like a playoff of Goonicorn for green unicorn?
Yeah, I think so. Yeah. Yeah, they're all unicorn themed, it seems like. FastAPI is also built on Pydantic and Starlet. So we talked about Pydantic. This does those runtime checks, and Starlet is another library. It provides an ASGI framework, and that just stands for Async Server Gateway Interface, to build web services. So you could actually build a website using Starlet, and it would be very fast and great as well. FastAPI is kind of like an abstraction on top of that. So it has this really fast framework underneath, and then it's adding these type hints from Pydantic and kind of bringing them together. And that's how FastAPI was built. Step 5, and once again, we're going to do this iteratively with step 4 a bit, is build the front end. We'll see this in a little bit. There's lots of frameworks for front ends. I just kept things very simple and used some HTML and CSS, but there's a lot of other good examples. You can use React and Bootstrap and all kinds of things. And we're also making some use of something called a Jinja template, and this allows us to inject return data from the Python directly into our HTML, so that it's kind of you can write pure HTML and then inject the data you want into it and do things like a for loop or an if statement and stuff like that. So we'll look at the Jinja templating system as well. Okay, step 6 is deploy to the web. As everyone was joining, I mentioned, hey, I just got this working like 10 minutes ago to deploy to GCP. I'm using GCP because that's what we're using right now at Ford, and so I want to get to know it a little bit better. But other cloud hosting providers will work just as well: AWS, Azure, DigitalOcean, Heroku, on and on, right? So we want to, when we've had talks before in this meetup, everyone like builds a website or something like that, and then the question that always comes up is, okay, how do I get this website on the internet? So I thought I would provide a little bit, a little show of how we do that as well. And finally, in order to do that, we're also going to make use of Docker. I think there's been previous talks just on Docker as well, and it automates the deployment of applications inside software containers. So we're going to package up our app in this container using Docker, and then we're going to deploy that Docker container on Google Cloud Platform. That's kind of all the intro material. Does anyone have any questions before we get started? Okay.
Hey, Dan, good afternoon. This is Bill,
Hey.
Calvier Grewal. So I have question, but I will ask in the end though. This is my first time, so I'll not slow you down. Okay, thank you.
Okay, yeah, if someone does have a question, feel free to stop me. I'm happy to stop and answer. Okay, so there's this website. So this is Jupyter, and I'm using it to do kind of the data parts of this, because I find it a little bit easier to check each step and do things with the data. So this is a website I found. It's called PokeDB.net, and it lists all the Pokemon. You can see there's some thousand of them, just about 1,000, right? And it's all in this table, in rows and columns. And we want for our I Spy the Pokemon, we want their name and we want the type. And you can see some of the types have 2 types instead of 1, right? And so we want to be able to select a first type and a second type and return Bulbasaur is grass and poison, and Ivysaur is too. Okay, so this is the notebook we have open. So the first thing we're going to do is import Beautiful Soup, because we want, once again, to scrape that website for information. We're also going to use request, and I didn't call that out in my presentation, but that's a library for getting data. And so you can even see that on the next cell here. We call request.getURL. So that actually retrieves the information from the URL. And we're going to use Pandas as PD, and that is just importing it. And we're going to use that for the data frames. So we're calling this URL Pokédex. We request or get, use request to get this URL. And then we're creating an instance of this Beautiful Soup class. And we are taking page.text. And this is the LXML that we're passing in. And you can see like, it's pulling the HTML off the website, right? So you can see the HTML, and you would scroll really far, right? Because it's got every single Pokemon in this HTML that we pulled. So next step, we're going to obtain information from the tag table. So there's a table in here called Pokédex. And I could probably search in here, I think. So pretty much our thing we have to go through here is actually like find the class of the table. And so it's searching for this table, the Pokédex, and then it's only returning this part. See how we have this table class down here? And so up here, there was this area called table class and it had an ID of Pokédex. And so we're finding that table with the ID Pokédex, and then that is the HTML table we're going to use. So instead of using all of the website, we just really care about this table, right? So we're continuing to scrape this and just grab the table from the website, which is what we want. And then the next step, we're going to obtain every title of columns with a tag. So I created a list called headers, and using a for loop. So for element in the HTML table, we want to find all th, and then take each element text, and that's the title. And then we are appending the head to this headers list. We're appending each title. So this is what it looks like. So it's scraping this website, and you can see the titles up here: name, type, total, health, attack, etc. Right? And so we looked for these th tags where the title is and grabbed all the titles and put it to a list. So now we have this table, and we have the headers for the table. So we're going to create a data frame now. And we're going to call it Pokédex. So we call pandas pd.dataframe to create a data frame, and we pass in these columns into the columns, the headers. So we said, hey, these are all the headers we have in this data frame. and then we want to fill this table. So we create a for loop. So we say for each table row in this HTML table, find the TR. So these are the rows. And then we take that row data and find all the TD. And so we've found a row, looked for the data in the row, and then this is a list comprehension. So we go element.text for element and row data. So we now have the row of this where we've, for each row, taken the text in each row and pulled it out. And then we look at the length of this Pokédex. And that is, we set that length, the last one, equal to the row. And then we return it. We have this table of information that kind of looks a lot like the table we just saw on the website. Is there any questions about like that for loop that we're using in Pandas?
Hey, Dan, I have a quick question.
Yeah.
So I think if I'm remembering it right, like grass poison is the first type for Bulbasaur. And I think it's because grass and poison were the two types, if I'm not mistaken.
Yeah. Yep.
If there were 0 types, like let's just say there was a blank, when you're running this loop, would you encounter any problems because like it would try to find something and there was no information in the cell?
So Mike, you're saying if one of these if this row was blank in one of the cells?
Yeah, I'm just curious. Would all of this still work even if there was some like incomplete data in some of the cells?
Yeah, we might have to do some more like cleanup. In this case, our data is great. But yeah, you might either want to filter out data or clean it up in some other way.
Okay.
I think if we didn't clean it up, it'd still be okay because it would be looking for a certain type in there. And if it was blank, then well, it just would return that data, right?
Okay.
But then you'd have extra data in the database, which isn't very useful, I guess.
Okay, cool. Thank you.
Okay, so yeah, thanks, Mike, for that questions. So there's a bunch of columns in here we don't really care about for our app. So next, I'm just dropping them all. So and I do it by the name of the column. So we go Pokédex.drop columns and pass in all the list of the names of the columns that I want to drop. And I'm just doing it in place. So that means the Pokédex object data frame itself is going to just be updated in place. And then you can see that following that, we have just 2 columns, with an index on the side. So there's the name and the type. And then Pandas has a function called toCSV. So this creates a comma separated values file, which we could open in Excel or another tool, and just writes it to that CSV. So we have gone out to this website, scraped the table off the website, put it in a Pandas data frame, and now saved it as a CSV.
Dan, I have a quick question.
Sure, Charlie.
Where did you use the LOC command in arriving at this? How can you mention a little?
You're talking about this Pokédex.lock length.
Yeah.
So we are yeah, I didn't really talk through that.
Well, we can talk later offline. I don't want to distract from the overall thing.
That actually confused me too.
So trying to remember why I did that. So let's just talk through it as a group. So the length here, we're getting the length of this data frame, right? And then we're passing into the data frame this Pokédex.lock and setting it equal to the row. So we are grabbing the length of the Pokédex, how long it is, and then we are setting the row equal in this data frame equal to that location of the Pokédex itself, right?
So the data frame like increases by 1 row each time. So the length is just like 1 up each time, and then the next row goes at that new length.
Exactly.
The next size. Okay.
Yeah.
Oh,
So we're building up the table as we go, kind of.
I did not, thanks for that extra. Okay. I'll have, thanks. Okay.
Okay.
Okay. Any other questions about anything?
I guess while we're on it, the second column has like a number. And it's kind of like starting 1, 2, 3, but then you get duplicate 3s, and at the end there's duplicate 905s. I'm just, how do we interpret that, or I'm just curious what that represents.
So there's like I'm sure
sorry.
someone's much more knowledgeable than I am, but there's like a numbering system of Pokemon. So like there's variants of them. So there's a Pokemon called Venusaur, and then it doesn't have a unique ID number, but there's also a Mega Venusaur, but it's still got the same number. And so this is like some standard numbering system for Pokemon. So if you went into, I don't know, any Pokédex and said, hey, what is number 214? It would return the same exact Pokemon.
Kids would be so disappointed, Dan.
If I may really quick, I think it has to do with some Pokemon can evolve or change form. So they'll have the same number. It's essentially the same being, just more advanced.
Yeah, thanks, Capri. Appreciate it. But like I think it's, Venusaur, Mega Venusaur is the same thing, but if it evolves from Bulbasaur to Ivysaur, then it has a number, right? So, okay. Any other questions about the web scraping? This was step 1. We got our data. Okay, so as I discussed, there's this open source tool called DB Browser for SQLite. Pretty nice little desktop app, and it allows you to like see data going into a database. So we're going to create a new database, and we'll call it, I already have one, so we'll call it database 2. And so you could, if you wanted to, manually add columns and fields and all that type of stuff, and you could actually write SQL to create the tables themselves. I'm not going to do that because we have a CSV file. So I'm going to go to File and Import and go to Data Table from CSV file. And then we created our Pokédex.csv. That was the last step in the Jupyter notebook that we were just looking at. And you can see there's 2 columns here, name and type. I have selected column names in first line, so that means the name and type are actually part of it. If you unselect that, it thinks it's part of the data, right? So it think name is, row 1, right? And so it's creating these 2 fields in here, and that's pretty much what we want to select. It knows what the field separator is and all that type of stuff. So we can click OK. So we have a table now in our database called Pokédex. And so you can see it has 2 columns, text, and two text columns in the database itself. So we actually want to modify it, and it's going to ask us to save the database. So we're going to click Save. And we actually want to add a column called ID, because we're going to want a key in the database. So databases work much faster if they have a key that they can reference. And we're also going to select this primary key here. So we want this primary key ID set. And I'll also move this to the top because normally like your ID is your first column, right? So remember we have the ID, name, and type, and the name and type was from the data we imported. And so now we have this table in here, and we got ID, name, and type, and we got all of our data in there, and we can browse our data. The IDs are all filled out. We got name and type. So I just find this tool is really nice at being able to create a quick SQL database and also like be able to view it as you go without, if you're using code or some other way to create a database is a little bit more difficult. So it's just nice being able to see. So we can, we got our database created. So that was, I guess that second step. So we scraped the web for the data, and now we put it in a database. Is there any questions about that? Okay. So if we go back to our PowerPoint here, just reminding everyone where we are. So we went through step 1, we got some data, we stored it in the database with SQLite. So now we're going to develop our Python schema. So now we're going to actually open our code. So I have, I created I Spy the Pokemon app here, and we're going to kind of go through what we need to create these API endpoints, our data, and our front end as well. Okay. So we talked about data schema. So what we're going to do first is we're going to go from SQL model import, and we want to import SQL model itself. So this is that library that I was talking about that allows us to, through Python code, define the schema of our database. So we create a class called Pokemon, and it inherits from SQL model. And we tell it that it is a table. Table is true. And then it has 3 fields. And these are the exact same fields we just looked at in the database. And notice the code here, they have the colons, which are the type hints. So what this means is ID is an integer, or, and you can only do this, I think, in the most recent versions of Python, maybe Python 3.10. Otherwise, you need to type something like optional, like, yeah, with brackets around your thing. But with, yeah, latest version of Python, you can just use this pipe operator. So integer pipe none, which means integer or none. And then we create a new field. The default value has no default value, and it has a primary key. Remember when we were in the SQL database, we said that this is the primary key to our database. So we want in our schema that we're creating in Python to also say, hey, this is the primary key. And then we also had a field called name. It is a string, and we have a type, and it's a string as well. Remember that type in a database is just like the first word space the second word for the 2 types. So that is really our database schema for this. It's pretty simple. It has 3 columns, and we created a class for it called Pokemon. We also are passing in a SQLite file name. So we named it, in fact, when we created it just a second ago, we named it database2, but we have this file called database.db, and we pass in the URL. So this SQLite database is on the hard drive, right? It's local. It doesn't require an extra process to be running. And so we're just going to pass in the SQLite URL to the file name that we just defined. And we're also going to create an engine. And this is all part of SQL model, right? Where we're going to create an engine for the database, and we're passing in the SQLite URL. There's echo equals true. This kind of shows what's going on as you're making database calls. Probably if we're really going to production, you might want to turn that off and not echo all your SQL calls, especially if you're getting quite a lot of traffic on your database, right? So this was our model. We wanted to create a schema, which was our step 3. I also have one other file, and maybe we're actually duplicating some of the stuff. We probably could have not had the SQLite file name defined twice on database.py and models. But this is just defining a function, and we're calling SQL model.metadata.create all, and then passing in the engine. So I think the way this really should have been is this stuff doesn't need to be here in our models file, but our database file has the actual parameters for the database. And we have a function to create the database in tables that we'll call that actually creates this instance of our database and passes in the engine for SQLite. So any questions about how to define a schema or the parameters for the database? Cool. Better than, yeah, maybe a little easier than writing a SQL select statement, right? So we can just do it in Python code. Okay. So going back, we're moving along. Now let's develop our Python schema for SQL model. We did that. So next we're on step 4 and kind of step 5. So we're going to develop our APIs and also develop the actual web front end as well. So we're going to create an app.py. And so if we scroll up to the top, we're going to do a bunch of imports that we'll go through. But to create a new app, we're going to import FastAPI and call this FastAPI class to create an app instance. We also need to, and I'll talk more about why we have some static files, but we need to mount the static files. So this is how you use static files, and why you would need a static file is things like CSS, images, stuff like that. You want to be able to make use of those static things. Sorry, does someone have a question? Okay. I'll maybe come back to the get types stuff, and this get session, I'll come back to that on why we need that too. And we're just going to talk about our 2 endpoints. So this is how we define an endpoint for the front end to call to get data. And that means the website front end is going to make a get request to a certain endpoint. In this case, there's 2. One is the default root URL, and one is an endpoint called type. So our website address /type. And these are going to get information from our backend, which is where the database is, where we have all the data stored, right? So our home kind of endpoint here, we're going to return templates.template response. So we have a file called index.html. So we actually want to load this index file. And remember, we talked about the Jinja templates, and we created a Jinja template up here. So we imported from FastAPI templating, import Jinja 2 templates, and created this template. And we gave it a directory. And so there's a templates folder right here. And in that is just a index.html file. And when someone calls this root API endpoint, we want to return this template response, and we're passing in what template we're using, which is index.html. And then we want to pass in this data. So there's the request objects. We also want to pass in the Pokemon. In this case, we're passing in no Pokemon. We have an empty list. And then the types. And I'll show in a second how we got the types. We'll talk more about that, but hey, we're starting to work on our home endpoint here, and we can start creating like an index.html file. This is just a HTML file, and we gave it a title called I Spy the Pokemon. We have some stuff here to center the content. And what this Jinja looks like is we're creating a form, and the Jinja is these brackets and percentage signs. And this is saying, hey, insert content here. And you can see you can actually write code in the Jinja template. So you say for type in types. If type is type 1, then you print a value. Else, you print this other type. So what this is doing is selecting the correct type that is currently being displayed. What I mean by that is if you select bug here and search, I don't have the website up again, shut down again, but it'll select bug when you have it brought up. So this is like the templating system. So what this allows us to do is our front end, our website is able to call this API endpoints. This is our index page, and request all the types from the back end. And then we're going to display in that dropdown all the different types that there are. So bug and dark and poison and all of them, right? And so this is just filling out these dropdown forms to allow us to select the types. And then there's a second drop down called type 2, and we're filling out all those. And so that's kind of how the templating system works, by being able to inject some code in here. Okay, so let's go back to our app. That was like the home API. So we want API endpoint, and you can see also the response class is we want to respond back with HTML. So the web browser is going to go to the root of the website. It's going to request that through the web URL, and then it's going to go get this, and we're going to return HTML, but we're going to inject using Jinja, we're going to inject into this index.html, and we're going to inject the request, the Pokemon data, and the types into there, into that template. Does that kind of make sense to everyone, what this home endpoint does?
Yeah, Dan, does it sort of sets up the option for the user to then run a query to the database, right? So it's pulled all these selection options so that you can then go to the next step. Is that?
Yep, exactly.
Yeah, it's sweet.
So how we actually get all the types, and I just want to do this once and then save it into a variable, because otherwise every time someone loads, makes a call to the website, it has to go back in the database and figure out what all the types are again and then re-return them. And there's only, there's less than 20 types, 19, I think. Someone probably is going to correct me, but, or actually 18, I think. So there's 18 types. I could have just created a table in Python and just listed out poison and bug and all of them, but I'm too lazy for that. So I just got them out of the database instead of writing them all out. And so to get data out of the database, we use this with session and pass in the engine. So this is that database engine that we have. And so we're using a context manager, and this creates a session in the database to get information or write to the database. And then this ensures that once it's done with that, it closes back out of the database. So that's why it's in this with statement. It kind of takes care of everything for us. And so the way we can get data out of the database is using these select statements. So I'm going to select, and remember our model for our database had a class called Pokemon, and then it had a name and a type column, right? So we want to select Pokemon.type. So that selects the type column, and it's looking for distinct values in that column. So this is the statement that we're creating to select all the Pokemon types and look for distinct ones. And then the next statement, we're going to actually execute that SQL query. So you go session.execute statement and execute all of them. And then I'm going to then take this and create a set out of it. So that's a Python data object that I guess doesn't have any repeating values in it. And so I'm going to do a for loop and say for type and distinct types, I'm going to update the set. And remember the data that's coming from this database, if there's two types, it's like bug space poison, and there's a space in there. So I'm using type.split and putting each individual type into the set, so that in our drop down, we don't see bug space poison. We just see bug as an option and poison as an option. And then we return these single types. And then this is just calling that and sorting them. So on our website, if you go back, these are all sorted in order, right? Okay, so this is maybe quite a bit of code, but really we're just opening the database, selecting a column, looking for distinct ones, and then I'm splitting that data apart. Once again, I could have just written out all 18 types instead, but if we added a new Pokemon type in the future, this would update automatically without me changing Python code or something. Yeah. So Is there any questions about getting all the Pokemon types out of the database? Okay. So we'll look at the other API endpoint. So in order to look up the Pokemon, we need to get the type of a Pokemon, I guess, get the Pokemon's name by its type. So we pass in Dark Dragon and we get a list of Pokemon back, right? And so that's the other API endpoint we need. So when you click on the search button, you actually get the Pokemon. So this is very similar. Once again, we're going to use this with session, pass in the database engine as a session. And the maybe special things here is on this drop-down thing, you could select bug and fairy, right? And that would be the same thing if someone selected fairy and bug, right? So we need to look at either one of them. So what we do is say if there is a second type, because not you could just select bug by itself, we're going to select the Pokemon that's in that first call, select this Pokemon table, and we're going to look for where the Pokemon type is type 1 space type 2, or the Pokemon.type is type 2 space type 1. If there is no type 2 at all, we're just going to select the Pokemon type equals type 1. Okay, so if you just selected the bug type, you'd go to the else statement and say, hey, Pokemon.type, does it equal bug? And then we're going to select all those Pokemon. If it's bug poison, then we're going to say, hey, does Pokemon type bug equal bug space poison? And if so, then we're going to return those Pokemon. Then we're going to execute that statement in the database and return all the results. And this is that template response again, right? Where we want an HTML response to this. And so we're going to update index.html, except this time we're going to pass in the request, the list of Pokemon, all the types, because we still need to fill out our drop downs, and then we're going to send in type 1 and type 2. And we need these two because we want to keep these updated with what was selected, and also write out what types were selected. And so this is the other endpoint to select the types. Does anyone have any questions about that endpoint? That's pretty much the back end of the app. So we have two endpoints, one for the home page, one to request the Pokemon by type. And then there's also one app.onEvent startup. And this startup event, whenever the app starts, it calls this create database and table. And if we remember, if we go back to the database, this is actually what starts up that database using the engine. So that just ensures that the database gets started with the app.
Dan?
Yeah. Hey, John.
Line 56.
Yeah.
You have a double equals.
Yeah.
So the query would not return a bug that also had a second type affiliated with it or associated with it.
Correct. Yep. Because if I select bug type only in the first drop down, if I just select bug, I don't want all the bug fairies, all the bug grasses, everything. I just want just bug types.
Well, what if I do want all the bugs?
So
you see what I'm saying? We're not enabling somebody to find bug with all of its associated or affiliated other types by itself.
yeah, and I did that on purpose because for this game, if my kids said, "Hey, I spy the Pokemon, it's a bug type," well, they weren't talking about a bug, you know.
So that is by
type.
design
Yep.
and by the design of the game. Okay.
Yep.
Thank you.
Yeah, no problem. And that's actually different. There's Pokédexes available, and if you search for a bug type, it'll return all the bugs and all the bugs something else's as well. And then, yeah, it doesn't help us play the game though. Okay, so this is the back end of the app. Yep, go ahead.
In the process of looking at this code, I'm starting, I wanted to ask about the PyLint or Pydantic typing, because what it seems like it's doing is it's teaching you the necessary pieces of the HTML or whatever is required in the process by forcing you to type it.
Yeah, that's a really great point. I didn't really talk about the Pydantic. So in the definition, so we add this decorator, the app.get, and in the function definition, we are adding type hints, right? There's a colon and it's a request type, and there's a type 1 is a string and type 2 is a string or none. And by default, it has a none value. This is really powerful because we are communicating our front end request to the back end. And if it doesn't get the type of data back that it is requesting, then our Pydantic will raise that as an error. It's even maybe more important if we were submitting data to the database. You know, if we had some type of login form and we wanted to log in and add data to our database, well, it's going to check that each piece of data as it gets it is the right type as well. So you don't have to do a bunch of like extra checks to say like, is this an instance of such and such, right? It just uses the runtime type hints to check that everything's the right type as it goes.
Cool, thanks.
Yeah, that was a great question. Thanks, Charlie. Okay. So, you know, the last couple of steps here, so we had FastAPI, we did that. We talked about Pydantic and Starlet a little bit. We talked about building the front end a little bit. So remember, we have these Jinja templates. We're injecting, when we call that API, you know, whether it's the root or the types one, you can see if we click search that or submit and reset, that these things are going to the right API. So reset goes back to the root one, for example, right? So if you hit reset, it'll reset the website back to the root URL. So what it's doing is we injected this information, the types. If we go back to the app, remember that's sent in with these types here, right? So we return this template response with types, and then this template is injecting those types in here, and then we can actually do a for loop over the types. And that's what the Jinja allows us to do. The rest of this is a pretty basic HTML and CSS, and I wanted to keep it pretty basic. So I created this gallery, and this is what creates the cards, which is the names on them. And so we do a for loop for Poke in Pokemon, and then we just print out the name. Maybe in the future we could add like pictures and stuff too on each card or something, right? That would be kind of cool. And then I just used some basic CSS. So there's some centered prompt CSS. And this is what centers everything on the screen here. The icons, the title, everything kind of gets centered using the CSS. And these are, if you're not that familiar with this, these are the cascading style sheets, and allows you to change the style of your website. And this is like the style, for example, of each photo in the gallery, right? So not too Python related, but you need maybe either to use some framework like React or Bootstrap or something, or I just created some basic HTML and added some CSS to make it look a bit better. And we pass in that CSS. Notice the style sheet gets passed in with this double brackets, which is also part of Jinja. And we've set the URL for static, and the path is style.css. And remember, when we created this, we said we mounted static to static files and gave it a name. And so that's that exact, the URL for static is getting passed into our index from the Jinja templating. So that's another place we use the Ginger template as well to pass in the CSS location. Okay, is there any questions about the website itself? So now we could run, actually, we can do it together. So we can actually run our website now. And we're gonna run main and run the app, right? Because that was the FastAPI call that we called it app. And what did happen here? Uh-oh.
Main.py.
Oh no.
No.
So sorry, I was typing the wrong thing. So remember, we need a web server. I shouldn't have called Python. So we're using Unicorn, and then we're passing in main :app to Unicorn, and that actually allows us to serve the site. So that was my mistake. And so you can see it's now served there. So it started this web app. And now if we reset this, this is that same website running, right? So we can select it and search for things, and it displays it. Okay, so that is step 5. And step 6, if everyone's hanging in there still, is deploying to the web. So we're gonna use Google Cloud Platform real quick for that. So this is what Google Cloud looks like. The first thing we need to do is create a new project. So like our project can be I Spy the Pokemon, be 2 or something, and we just create a new project in here. And you can see it says creating a project, I Spy the Pokemon 2. And yeah, so we can select the project. And now there's a project set up in Google Cloud for us to do things with. So we can deploy to this project. We're gonna use something else called the artifact repository to upload our Docker image as well. I'm gonna select back the one we were using, the I Spy Pokemon, but that's the first step, is to create a new project. So we also, there's a command line app for Google Cloud, and it's called gcloud. So we can do things like gcloud auth login. I'm already logged into this, but this would be the first step to get running. So you log in, it's going to give you a URL to follow, and then you log in with your username using the website. And so that allows gcloud to make use of your login for Google Cloud. So if we go back here, there's kind of one other file we need to look at. If you want to deploy this, we want to create a Docker container. So what this Docker container is, once again, this is containerizing our app so we can deploy it to Google Cloud. And I'm using Poetry for my app. So Poetry is a kind of manager for the Python package, and it allows you to pip install your app. And it has your dependencies for the app. So for example, we have FastAPI and Unicorn and SQL model. And so when we actually deploy the app, we need to use Poetry to install it. And I'm using a 2-step thing, a Docker container. So first I'm pip installing Poetry. I'm copying over the project.toml and the Poetry lock for the app. And then I'm actually exporting it into a requirements.txt file. And then we are running a second stage container. This Python :3.10, this is a Docker container that already exists that has Python running, and it's in the Docker registry. So you can just make use of it and use the latest version of Python in the Docker image. We're setting a work directory to /code, and we're copying from this last stage our requirements.txt file, and then we're pip installing all the requirements that we have. So it's pretty much pip installing all this stuff here, but not the development dependencies, because we don't need PyTest or Pandas or Beautiful Soup to run our app on Google Cloud. Okay, so then we're copying our code and our database over, and then we are running gunicorn with this unicorn worker. So this is the actual like what's going to serve the website, and Google automatically sets this port environmental variable and passes it in when you run. And then we're running is Python Pokemon.app and running the app. And it's running 8 threads, but you can modify that if you want. So this is like a Docker file. I don't want to spend too much time on this because it's getting late already, but this is how we're kind of packaging our app into something that we can then deploy. So we logged in. We want to actually build our app now using Docker. So if we go up a little bit, I'm typing in Docker build and we're tagging it. We're tagging it, and this is where in GCP we are. And what I mean by that is if we go to Google Artifact Repository, we have something called I Spy the Pokemon and an image, and you can copy this, and you can see it's us-central1 docker.package.dev. And so this artifact repository is actually keeping our Docker image in here. And so we can copy this, and that is where we want to actually tag our image to. It's the same exact path, right? I spy the Pokemon, and we're going to call the Docker image we're building just image, but you can use a different name if you want. And the dot means we're going to build this from the current directory. So you click that, and then it's going to build the Docker container that we just defined. And it should do it pretty fast, right? So it created this using that Python 3.10 Docker image and built our dependencies, installed them all in the Docker image. And so they're all set now. So now that we have the Docker image set up, we need to push the Docker image to that location. So we can go ahead and go Docker push the same address, us-central1 Docker package. And this is that same image that we just built. And it says using the default tag latest, but if you were like tagging it with different versions, it says layers already exist. If I was doing this for the first time, it would take probably 5 minutes to upload all the different layers of the Docker image, but I already pushed it to save us a little bit of time. So this is the latest version. You can see that our image is uploaded here and posted, in here, and you can see the images that were uploaded, right? And so our Docker's been put in there. So then what we can do is the last thing is we want to actually deploy our app. So we're going to use gcloud run deploy. We're going to pass in our Docker image that we just uploaded. We're going to use a managed platform. This will use Google App Run, which takes this container, spins it up and runs it for us. The service we can just keep as the default for the image. That's fine. So it says deploying. It's looking for this revision. So it says cloud run service. It's in this project, I Spy the Pokemon, the region's us-central1. If this was the first time, it might ask us what region we want to deploy in, but I'm in Michigan and us-central1 is close to me. So that's why I chose that one. But if you're in a different region, you can select a different one. So it says, hey, we created our revision, the routing traffic's done. It's been all deployed in this service URL. Now, if we had a domain, we could actually create an ispythepokemon.com website or something like that. I haven't bought a domain for this app or anything, but it's giving us this URL. So one thing that I noticed about this when I deployed it right before is it doesn't look like the CSS is there, does it? But the app is running, so you can type like a bug poison type or something and click search, and it's printing out all of them. So our app is working. And if we were troubleshooting this together, we could open the dev panel, and you can notice it says mixed content. this app, the CSS, the request has been blocked. The content must be served over HTTPS. So there's some issue with like maybe the URLs that we're passing in the app where it's trying to use a HTTP instead of HTTPS. And it's blocking it because you're on an HTTPS app, and for some reason it's trying to pass in normal non-secure traffic. I'm not sure why it's doing that off the top of my head, but I'm sure we could troubleshoot it and find out and get it loaded and looking like our one that looked locally, right? But that's pretty much how you would deploy a website to the internet, and then you could add a domain to it. Is there any questions about deploying using Google Cloud?
Yeah.
Hey, John.
I missed one thing during your talk. So SQL Server is not running on Google Cloud, right?
It is not. Oh.
So you somehow took the information that was in SQL Server on your desktop and saved it as a database.db file.
Yeah.
I guess I missed that part. Was that SQL one of your packages, right? Did that?
Yeah, so that is the beauty of SQLite a little bit, right? So if we were, if we want to use Postgres or some other database, then if we wanted to
I see.
use it on the internet, we would have to then use a SQL service. I mean, you could put it in a Docker container as well, but that's not very good to have like I guess, especially if you're writing data to the database, you probably don't want it hosted in a container. But that automatically becomes way more complex. Right now, you're adding a whole bunch of stuff, maybe additional Docker containers, or you're adding a hosting service for your SQL, and now you have to figure out how to create the data initially in your database and all that type of stuff. So you just like increase the complexity of your app like 5 times or something. So we're just using this database.db file. It uses SQLite engine super fast, and we can just include it right with the Docker file that we had.
So you're using that other package to access the data in the database.db file. You're not using SQLite to access it. You're using that, I forget the name of it, what was it?
So we had this database browser to look at it, but Python has a library called SQLite 3 built right in. So we were using SQL model through SQLite to query that database object directly.
Yep. Now I got it. All right. Thank you for your help.
Yeah, no problem, John. Any other questions?
I guess just to be clear, the database is in a SQLite format, and you can access that database with anything that is SQLite compatible.
Yep.
That's a fair statement. Okay.
Yep, exactly. So we use SQL model to access it, but you could have, you could use C code or use SQLite 3 Python library or all kinds of stuff, right? So once it's in that format, then it's pretty easy to use in any app.
Hey, Dan, this is Balbir.
Hi, Balbir, how are you doing?
I'm doing fine, thank you. Hey, for the spirit of open disclosure, I also work for Ford Motor Company.
Okay, awesome.
But I have absolutely no prior knowledge of any language. So what I am trying to do, this bug in my head, I am trying to develop an app. I have created the high level architecture just on the PowerPoint, what the input should be, what the output I'm looking for. But I need to now, since I don't know anything about any of the languages, anything, could you believe it? I survived almost 28 years at Ford without knowing these things.
Never too late to learn though, so that's good.
So how do I go about, because I have no idea of any of the languages, how do I start to learn some basics? or, how would you suggest I go about? I have created the overall, how it's supposed to work, 30, 50, 60 slides, inputs, outputs, the API, what databases need to be hooked up to, kind of a thing. But, this is the part that I don't know anything about.
So it's maybe, it is, I showed all the different libraries, all the different components, all that stuff. It's probably pretty challenging if building like an app from scratch as the first thing. But, like Ford has Anaconda, so you can install Python locally. And I think maybe taking some initial steps of, hey, I'm going to, scrape some data off a website and figure out how to do that. Or I'm gonna, building up those like little tiny building blocks where you're like, oh yeah, I can use Jupyter Notebook and look at some data and put in a Pandas data frame. I think all those types of like small incremental steps, Python's pretty accessible, so it's pretty easy to learn those maybe individual things, and then eventually start to put those things together in like an overall app or something like that. So that's what I would recommend. I think
is that really hard part, to learn all that stuff? Because what you explained, I only got like maybe 15% of it.
Yeah. So I am self-taught in Python as well. So that's at least how I learned, is building little projects. I actually like contributed to open source stuff and just kind of like learn as you go. But I think the best way to learn is actually have something you want to build and figure out little pieces of it. At least I learn a lot better, like hands-on something I'm trying to achieve, rather than like, I don't know, watching videos or something like that. And then it's kind of hard to apply, right? So you can definitely, I didn't know any Python a few years ago, so it's definitely possible to learn, and it's beginner friendly. And I'm sure lots of people online are in the same boat that they're learning, so it's good.
No problem. Thank you so much. So I should start learning Python, okay.
Yeah, little projects, automate little things, or
Okay.
Start building little pieces of the project you have, for sure.
Awesome. Thank you so much. Thank you. I may bug you.
Okay, sounds good.
If you don't mind. All right. Thanks.
Yep. Any other questions, anyone? Hey, Jeremy, thanks for joining as well. We'll see you online.
Dan, that was a great presentation. Just really outstanding. Thank you.
Yeah, thanks, Mike. Oh, Evan's walking. I like it.
Yeah, gotta meet folks for trivia. That was a great presentation. Thanks so much. I'll have to rewatch the Docker stuff because that's still a major weak point for me. So